All right, guys, I got disconnected, or we got disconnected on the last video when we were factoring trinomials of the form ax squared plus bx plus c. But I'm going to finish up. I'm not going to finish up on the same sheet that I was on. So I realized that I needed more room in order to show you all how to work I and J. So I'm just going to be on this app working I and J, and you follow me. You just follow me on it. Keep up with it in your notes. Write these in your notes. Pause the video as you need to. But I know we already started on I on the previous video where we were connected, but I'm just going to start on I again. All right, so the first step is to look for a GCF. And between 4, 10, and 6, the greatest divisor is a 2. 4x squared has an x, 10x has an x, but negative 6 or minus 6 doesn't have an x. So I cannot include x in my GCF. Okay, what do you do with your GCF? You divide each of these terms by your GCF. That's going to leave us with 2x squared plus 5x minus 3. Now I'm going to do something a little differently than I did on the previous video. This is my remainder. And I don't want to write it right there because I need to start working underneath here. All right, but this is my remainder. Your remainder is what's left over after you divide. That's my remainder. Your GCF always goes with your remainder. My GCF was 2. Now, in the last video, I wrote it over here, okay? I'm not going to do that because I'm going to work over here. And I don't want to continue to keep this 2 of my GCF over here in this area. I'll put the 2 back, this GCF of 2, back in the end. I want to try to ignore it right now. But what I want to do is right there, I have 2, which is your original GCF, times your remainder. I'm putting my remainder in a bracket because I'm going to be able to factor this remainder. If you can factor your remainder, you need to try to keep it separate from your original GCF. Okay? All right, so what you need to do is check to see if the remainder can be factored. Okay, so we're going to check to see if that remainder can be factored. Again, this is our remainder. Let me highlight it. That's our remainder. I need to check to see if that can be factored. All right, so what I'm going to do is look at it. It's in the form ax squared plus bx plus c, which means it can be factored using the x method. So that means I can multiply a times c and then put b here in the bottom and try to figure out what the numbers on the sides of the x are and rewrite the middle term by using those numbers as coefficients for my rewritten middle term. All right, so here A is 2, B is 5, and C is negative 3. So when I multiply A times C, and I need a little more room. When I multiply A times C, I actually end up with negative 6. And then my middle term will be, my bottom number will be 5. All right, so I want to see what multiplies to give me negative 6. Because it's negative, I know that I have a positive times a negative. Okay, now I look at this bottom number here and I say, okay, it's positive. So that means the larger number has to be positive, because if you subtract two numbers, you determine the sign by looking at what number is larger, okay? All right, so I'm going to subtract it. The signs are different, but the sign has to be positive, so the larger number must be positive. Okay, so now what I'll do is I'll just think about two numbers that give me negative 6 when I multiply, but yet 5 when I add. So that's going to be 6 times negative 1, which is a negative 6. And 6 plus negative 1 is your 5. All right, so I'm going to put the numbers 6 and negative 1 on the sides of the x. Now keep in mind, when you're factoring by grouping, you don't use those numbers on the sides of the x in your factor. So I wouldn't write x minus 6 and x minus 1. Those numbers on the sides of the x are meant to rewrite the middle term. So here's the middle term, 5x. So I'm going to use these numbers to rewrite the 5x. And because it has an x, I'm going to go back and put an x here and an x here. So this I'm going to keep. This I'm going to rewrite. And this I'm going to keep. So I'm going to factor it by grouping. Again, I'm just factoring the remainder. And I know some of you all are saying, well, what do you do with this GCF of 2? I'll show you what to do with their original GCF of 2 in the end, okay? You're not going to forget about it. You're not going to worry about it right now. All right, so let's rewrite. So we have 2x squared plus 6x minus 1x minus 3. And I'm going to factor by grouping because I have how many terms? 1, 2, 3, 4. 1, 2, 3, 4. There you go. All right, so I group mine by using colors. Okay, so that makes the group. And I'm going to do the GCF over here. And this makes a group. And I'm going to do that GCF over here as well. All right, so let's go ahead and start off with the GCF on the first group, the one with the yellow block. So that's 2 and 6. The greatest divisors are 2. That's x squared and x. So you choose the one with the smallest exponent. So what I'm going to do is divide both of these by 2x. So I will end up with, those will cancel. I'll be left with x. These will cancel. I'll be left with plus 3. 6 divided by 2 is 3. Now this is your remainder after you divide there. So what do you do with the GCF? Well, you take this GCF and you write it in front of your remainder. And you put your remainder in parentheses. Then I move on to the blue block. The only thing they have in common is a negative 1. So I divide both by negative 1, and I end up with x plus 3. Now that's your remainder after you divide in the blue block. Okay, so what do you do with this GCF? Well, you attach it to the remainder, negative 1, and the remainder was x plus 3. Now you have a common binomial factor. So we're doing the same thing. The only thing is we had to divide by 2 in the very beginning to get that original GCF. All right, now my common binomial factor is x plus 3. So I'm going to divide each one of these by x plus 3. And these are going to cancel. And I'm going to be left with, let me move this up. I'm going to be left with 2x minus 1. Okay, now, what do you put with this remainder? With this remainder, you put the last common binomial factor. So you take this and put it with that remainder. So you're going to end up with x plus 3 times 2x minus 1. Okay, now, it looks like we're done. Okay, but we're not. Okay, let me show you why. Well, if you go back, what was the original GCF? Basically, I see a common binomial factor that's acting as a GCF. I see a GCF of negative 1. I see a GCF of 2x. And I see an original GCF of 2 right here. What do I do with that 2? Well, where was the 2 sitting? Where was it placed to begin with? Where it was placed first. So what do I want you to do? I want you to go back down here take that original GCF and place it right here, back in the front first. Okay? It is our original GCF. You put it right back. Make sure to put it back in the end. So after you factor the remainder, if the remainder can be factored after you divide by GCF, don't forget in the end, put your original GCF back. All right, let's go ahead and look at another one. And let's look at I. This was I on the video from before. Not I, but J. We just did I. All right, 9y cubed plus 3y squared minus 6y. Okay, what you want to do is, again, always check for a GCF to see if you have one. Okay, 9, 3, and 6. What's the greatest divisor? That would be a 3. Also, they each have a y. So right here, there's y, there's a y, there's a y. Well, which one has the smallest exponent? Well, that would be y to the first. So I'm going to include the y to the first in the GCF. So what do you always do with your GCF? Well, you take it and you divide each term by. I'm going to divide this term by 3, y to the first. I'm going to divide this term by 3, y to the first. And I'm going to divide this term by 3, y to the first power. All right, when I divide 9y cubed divided by 3y to the first, I know 9 divided by 3 is 3. 3 minus 1 is 2. So that's going to become 3y to the second. These 3's will cancel, and then I'm left with 2 minus 1 to subtract my exponents. So that puts me at just plus y. And then I have these y's that are exact matches that are going to cancel, and negative 6 divided by 3 is 2. And that's a negative 2, guys. All right, this is acting as my remainder. It's the one that I'm going to check to see if I can factor, okay? You always check to see if you can factor your remainder. Always. When you start off with, when your number one is a GCF. So anytime you get a GCF in step 1, you always have to check to see if your remainder can be factored. But that's only if you start off in your step 1 with a GCF. Then you must do this, okay? All right, so I'm going to see if I can factor that remainder. So does the remainder fit any form that I know of? Well, it's a trinomial. So I need to see if it's the trinomial with a leading coefficient of 1 or something other than 1. So if you take a look at it, you have 3y squared plus y. I'm going to put an understood 1 there, minus 2. Well, this is something other than 1. So if you have a trinomial with a leading coefficient of something other than 1, you're going to check to see if you can use the method A times C and then B. So let's see if we can get numbers in the size of the X if we do it this way. All right, so A is 3, B is 1, and C is negative 2. All right, A times C would be negative 6 and then a positive 1. All right, because the negative 6 is negative, I know I have a positive times a negative, but my bottom number is positive, okay? So I know my larger number needs to be positive. All right, so let's go back. So that's going to be 3 times negative 2. That's how I get negative 6. And 3 plus negative 2 is how I get the positive 1. So I'm going to use a 3 and negative 2. And I leave a little space, okay? I leave a little space right in here because I know I'm going to have to put a variable behind it because this A is greater than 1. When A is greater than 1, I rewrite the middle term using this stuff, okay? All right, now what variable will go behind it? Because this is an understood 1, and then there's a y right there. There's a y. So what I want to use is a y over here. Okay? All right, so I'm going to use a y. So I'm going to put 3y and negative 2y. I'm going to keep this, rewrite, keep. So I end up with 3y squared plus 3y minus 2y minus 2. Okay, now I'm going to continue to factor because I have 4 terms. I'm going to factor by grouping. And I see that, and let me group these together with color codes as you all are used to me doing. All right. Okay, let's color code this. So I'm going to group these two together and do the GCF. And then I'm going to group these two together and work on the GCF. Okay, and after I get the GCF for both, I'll do the common binomial factor. All right, so the GCF of the block that's in yellow, each one of them have a 3 and each have a y, but don't choose y squared. Choose the y that has the smaller exponent, so that's going to be 3y. Now, anytime you have a GCF, automatically divide your terms by that GCF. I'm going to divide the terms in yellow. These are going to cancel. That's an understood 1 for the exponent. 2 minus 1 is 1, so it's y to the first, or just y. 3 cancels with 3, y cancels with y. You're going to be left with just 1. Stuff over the same stuff over the same stuff is 1. Or you could just say 3 divided by 3 is 1. And the y's cancel. All right. So now this is your remainder when you divide it by what? Well, 3y. So that means 3y and y plus 1 go together. Now I'll work on the GCF for the other one. Well, the only thing they have in common is a negative 2. So I divide both by negative 2. So I end up with y, because these are going to cancel, plus 1. Negative 2 divided by negative 2 is 1. All right, so this is your remainder for the block in blue. Well, what do? You take this negative 2, this GCF, and you put it with the remainder for the block in blue. So you're going to have negative 2 times y plus 1. Now you should see a common binomial factor. Okay, your common binomial factor is y plus 1. So anytime you have something in common, you just go ahead and divide by y plus 1. Divide by y plus 1. These are going to cancel. So we're left with 3y minus 2 as a remainder. Well, it's the remainder after I divided by what? After I divided by y plus 1. So therefore, I put y plus 1 with the remainder 3y minus 2. Okay, but I'm not finished. And most students would think, oh, we're done. No, you only factored the remainder. You only factored this remainder to begin with up here. That's all you factored was that. Okay? So this remainder is that stuff we have at the bottom. But what do you do about the original GCF? Again, what did I tell you to do with the original GCF? Go back and put it with your final factors. So the original GCF was 3y. So I'm going to go back to my final factors and add my original GCF, 3y. Okay? This is the original GCF. It has to go back to the front. Okay, it has to go back to the front in front of those factors that are left over. These factors only came from the remainder, but then you have to consider the factor that you started off with, which was the original GCF, and then you put it all together. So that's your answer, okay? All right, and that's that, guys.